Okay, we are back. Um, so we've created our variances that are coming through here. I'll teach you about this stuff here in a minute, how to do it. So this is our variance, annual variance, monthly volatility, you would say. And this is for the evaluated portfolio. And this is the, given a year, the monthly volatility for the equally weighted portfolio. And if you've created your macro correctly and assigned it to a key, it really wasn't that big a deal to create all these different values. So we're going to go and create the descriptive statistics of it. Pretty straightforward. Right, we're just going to calculate the average of the evaluated column. The reason I'm doing it this particular way is to show you that the blanks really don't impact. Excel understands what a blank is and therefore doesn't put anything in, so you don't need to collapse the column so that all you see is a strict row of numbers. Calculate our standard deviation, our min, and our max, and we really don't need kurtosis or the skewness of this particular graph variable for a couple of different reasons, but I'm not going to get into the empirical details of those right now. Anyway, so our next step is to generate a frequency diagram, and again, this is for the value weighted, so just to keep everything in order here. This is the value WGHT portfolio, or this is the market portfolio. And just as we've done before, I've calculated my step here, and I'm doing it this way in this particular, because we don't, in this particular example, just to show you, you don't have to do this long form. You can actually make a bunch of shortcuts, jam everything together. It just becomes a lot more confusing. And one of the things you need to think about as you're creating these spreadsheets is that other people will end up looking at them. When you're at your job, people will say, show me your spreadsheet. And if it is something that only you can understand, you've done a horrible job. Other people can't follow it, therefore they can't proof you, they don't understand what's going on, and it creates issues. So, but in this case, remember, we were doing a plot for every month, and I picked 30 groupings. I'm over, 74, 75 years of sample, so that times 12. In this case, we only have one observation for every year, so I've set my the number of bins decreased to 15 from 30 before. Calculate step the same as we did before. Max minus min is a quantity divided by the number of steps. And in terms of putting my bin areas together, same equation that we used before. It's the minimum plus our increment times whatever the step is going to be. Excel has a bit of a problem here. It just but what is the problem here is that it's displaying just too many digits, and we need to decrease the number of digits significantly. And even though you get it set up because it's an equation, it tends to lose its sense of position. Anyway, our next step is to use the frequency command. We've gone over this before. Remember, the key thing here is it's equal to frequency. We highlight our return series. We highlight, well, it's not our return series actually, it's our volatility series. And the frequency understands blank too, so it doesn't count blanks. If there are blanks in your column, it's not going to include them, which is why I'm including this as part of your process. And then what our bins are. And again, the key thing here is that you highlight the entire area that you want, type your equation in, and then once you have your equation, you hit Control-Shift-Enter in order to get the frequency. So that's all pretty straightforward. We've gone over it before, so I'm going to not spend a lot of time on it. Our next step is to take a look from a market-wide perspective, the idea of risk and return. So in finance, risk represents the standard deviation. And we're going to proxy, or in other words, we're going to estimate what the standard deviation is, or what the risk is, by just squaring what the return was. So my sigma value is simply a given return squared. So I've got, for my my value-weighted portfolio, I already had it done. This is what we want to look at. So this variable is just B3 squared, B4 squared, and then we want to see, this is just the difference. So it's 1945 February minus 1945 of January. So we would say this is the increase in risk if it's positive, or the decrease in risk if it's negative. And this is, again, we're always proxying. We're looking for variables that can kind of estimate our issue. So just to show you how to do this, here's my equally weighted portfolio. Put the initial equation in. It's equal to, I click on the variable that I'm interested in, and then I use the caret right above the 6 character, the number 6, so shift 6, and then I want 2, that just means squared. And then I'm going to drag it down a line, and that's going to create the next one down. And then I'm going to do my equation for the difference. So I'm going to say just it's equal to, and I pick February and I subtract from it January. So that's the difference. Now at this point I could highlight this and go ahead and drag it down, but I don't want to do that because I want to show you the nice simple way to do these things. So we're going to click on the first box, and you'll notice over here that we are on cell I3. And what I want to do is I want to take cell I3 and cell J3 and project them all the way down to the end of my series. So what I'm going to do is come over here, and I want I3 colon J3, or not J3, J841. So that's at the bottom of my series. And I'm just going to hit return. And remember, at the beginning of this, I told you to write down where your series ends, what the number is. And then we're going to go ahead and fill, and just fill down. Lo and behold, all of our equations are in there. C4 squared, C6 squared, C10 squared, and what the difference is. So we have our series that we're interested in. And then this is going to be the change. So I'm going to do the CHNG, and then hit alternate enter to get a new line, sigma, and alternate enter to get a new line, and then equal to reference my equally evaluated portfolio. So the next thing is to run a regression. And here's my value regression. And the idea is that we want to look at, is the return a function of the difference, the change in risk. So this is my y variable. You notice I have to start now at 3 rather than at 2 because I can't calculate the change until I've gone forward a month. So is this, the question becomes, is does return increase as risk increases? Okay, or does return decrease as risk decreases? So we want to run a regression. There's another function called linest. We're going to skip that one for now. We're going to end up using it. But I'm going to show you the point and click methodology, I guess we would say. So we're coming over here to data and the data analysis. If you do not have this data analysis and solver in here, you're going to go over to file. We're going to go to options, add-ins, and then I can't click them now because they're already added in, but you want to click your VBA toolbox. So you would like go here and click, 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 and say go ahead and add them, and it will go through and add them into your system. So again, data analysis, what we want to do is click on regression, okay, and we want our list of Y's. So our Y's are going to start here. I'm sorry, here. We got to get to the top. Here at C3, so because that's the first time I have my change available. And then type in the colon button, and now we want to go to 841. And then my X's are going to start again here at 3, and then our colon, and we're going to go again to 841. Now we're going to include our labels, or not include our labels. It really doesn't matter either way. We're going to put the output in a new worksheet, and the new worksheet is going to become EQAL reg. So we're going to name it. And that's good. So it's going to give us everything that we're interested in. Click OK. Here's our results in equal reg. We can take a look at some of the coefficients. So on the equally weighted portfolio, what we see is that our intercept on the coefficients is 0.01. This is the standard error. This is the t-statistic, t-stat, which tells you that it's positive and significant, meaning the average is actually positive. This is our explanatory power, which is close to 0. What we're really interested in is this coefficient, and this coefficient is my variance, or my change in variance, just as an idea. And we see it's positive, but it's also not really significant, which tells you that an increase in risk implies an increase in return, but we're not particularly confident that that's going on. Where with my value-weighted portfolio, I got a negative coefficient. Again, this is the variance coefficients. We got a negative coefficient, but also not statistically significant. So on this regression, it implies that an increase in risk leads to a decrease in return. Now your sample is a little bit different than my sample, so your results are going to end up being different than mine. Possibly close, but different. So we're going to go ahead and hit save to save the file. Don't forget to do saves periodically so you don't lose a lot of material. And that pretty much completes everything that we want to do with our basic market data. The next topic we're going to cover pretty quickly, one video, is the min-max investment, or the winner-loser investment model. All right, thank you very much. Bye.